Hello guys, in this video I will show you how to get started with the ORCA hand. When you open the box, you can see the ORCA hand fully assembled, some spare parts and power supply. This is a VTech hand. It currently uses the VTech board, and I'm going to just show you how to get started, how to install the software, and how to just run joint angles with this hand. So I'm going to take the power supply out of here and the USB cable, and then also I'm going to take one of those components here is the tensioning tool. This is right here, and then you can see we have some spare skins, some ratchets, some tendon material, and we'll follow up with videos later to show how you can repair such a hand. So I'm just going to quickly close this box here. So to get started, get an overview of the hand. This hand has 5 fingers, 17 degrees of freedom. It has 4 degrees of freedom in the thumb, and it has 3 degrees of freedom in each finger. So we have the adduction, the MCP, and the pip for each of those fingers, and we additionally have the CMC, the thumb, and also adduction, MCP, and dip or pip. And then you can see that we have some fans here and the control board here in the back, and those hulls can be detached, so you can look inside and see the motors and the tendons. It's also worth mentioning that this hand here comes with tactile sensing. So we have tactile sensors on top here, which have cables that run through the hand and go to an electronic support here in the back. So to get started, we take this cable, we take the power supply, we plug this into the wall. We connect this to a board, and you can see right away that the fans will go on. Now we're gonna also connect this board to the computer. Right now we only connected the power, we also need to communicate with it. So we can plug in the USB-C cable right here, and then take the USB-C cable and plug it into your computer. The sensor data comes through a different USB-C cable because currently we have the standard motor controller board, which is not connected with the sensing. So we have 2 separate cables. In the future we'll also have one board combining everything. In order to get started with the code, you can look in our GitHub repository, and there are a few repos. The main repo is the ORCA core, which is the main control software for the ORCA hand in Python. And the easiest way to get started is just to clone this repo and install it. Otherwise you can also install it through PyPy, although we are now just gonna clone this repository, and so we can also make live changes. I'm just gonna go ahead in a fresh folder, which is empty. I'm just gonna git clone this repository, and now we're gonna cd into it, cd ORCA core, and as you can see here, we can either run this with UV, or we can pip install it as a package with a virtual environment. I'm just gonna run this command right now, and I'm gonna activate the shell. There we go. And now should be ready to go. So how we interact with this hand, let me quickly walk you through this repository. We have scripts, which are the easiest way to just run everything. And for example, we have a script for calibration or for tension. So tension is a script which moves the motors in a certain direction, and we can use this tool to tension the tendons. And then we have the second most important script that you will need is the calibrated PY script, which runs calibration so that the motor positions can be mapped to the joint positions. Now, for the sake of showing you how to use this repository, I'm gonna just use the code right away in Python. You can just run the scripts if you want, but let's run the code. So I'm just gonna go and open Python here, and I'm just quickly gonna run the code that I previously ran. I'm just gonna import ORCA hand. I'm gonna create an instance hand of the ORCA hand. It works. It tells me none of the joints have been calibrated, which is expected. And the first thing I will do to move the hand is I'm just going to connect the hand. The connection is successful. You can see this is the port I'm using. This is the baud rate I'm using. If you have issues with that, make sure that your computer can access the port and you have established a connection. Now there are many different things I can do with this connected hand. The most important thing that we got to do before we operate this hand is we need to tension it. So right now the fingers are very loose. So currently you can't really control the hand, so there's a lot of slack in the tendons, and this is on purpose because we ship this maybe like this, or over time the tension releases. This is a bit extreme, you won't see this in reality, but anyways, we're just going to run hand.tension, and what this will do is it will just move the hand to a certain direction, move the hand into the other direction as well. And now it stays at this current position, and we can use this tensioning tool to tension. So we have spools here. Each spool corresponds to one of the tendons, two tendons, like flexor and extender. And I can just simply use this tool to now move the top spool and tension the tendons. As you can see, some of them I need to move quite a lot. And the important thing is that we don't want to over-tension the hand. So what I'm doing right now is I'm checking whether there is enough tension on here. So right now this might need a little bit more tension, so I'm going to do one more. And this one needs quite some bit of tension. Okay, this is okay, maybe one more. Same with this side, this is okay. Okay, so this is quite okay. Maybe this needs some more tension. There we go. Now we're going to do the same with the back of the hand. Just quickly cover this hand again. Just going to open up like this. And here's a bit tricky because the board is connected to the back hull, so it doesn't go up all the way, but you'll still be able to tension this. There we go. And so how the workflow usually is that it's like you tension the hand, and over time some slack will build up, and so you might want to run this tensioning script when you realize that there is some slack in the fingers. This should stabilize after a few hours of operations, so don't worry if in the beginning you need to tension it a few times. It will get better with time. So right now it's tensioned, and usually this is how it should also be delivered, but just for the sake of showing you how it works, I did this tensioning here. Maybe this one needs one more. There we go. Perfect. So now the hand is tensioned, and we can move it again. We can cancel the script because now it still has torque in the motors. Now it releases the torque, and I can move the hand again. Now I can move the hand to a neutral position. And as you can see, now all of the joints don't have any slack, which is good for control. We're going to have a joint sensing hand that is coming out in a few months, maybe 1 to 2 months, and there the slack is not too big of a problem because you can compensate it with sensors right in the joints. But still, the better tension you have, the better your controls will be. So right now this is quite good, and we can run the calibrate script, hand.calibrate. What this does, it goes for every joint to the maximum positions, and it can estimate what the joint position will be based on the motor position. This is because we have a linear routing, and this is one of the unique designs we have in the ORCA hand. So it goes quite fast. It also does it with the wrist. It only does the wrist once, because usually in the belt you don't have a lot of slack going on. And there we are. So we just calibrated the hand, and basically this is how it should be. So all the fingers should be straight, the abductions should be in the middle, and the thumb should have this position. And now I can just command any joint angle because now it's fully calibrated, as you can see in the code. If I go out of Python here, I can run Python scripts neutral dpy, and there we go. We go to this neutral position. And in order to now control the hand, you can look at one of the examples, like we have a script called stress test, which runs operations. And you can see here we can put the joint positions at certain values, and we can just say, okay, we can set joint positions and then pass this object into there. And if I now run this script, it's called stress test. The hand will just move between two different positions quite aggressively, and this should just, it's just an example of how you can move the hand. And we also have the temperature here. Right now the temperature is pretty cool at 30 degrees. Of course, as this hand will move now, it will heat up. Because of the two fans, it should not overheat. I will just quickly stop this right now and go back to the neutral position. Now I will quickly show you how the tactile sensors work, how you can connect to them, and how you can read out the data. So as you can see, there's one USB cable which comes out from the back, which goes through here and comes out here, which is specifically for the tactile sensors. In future versions, we will have one board. You can later upgrade if we bring out our own board at some point. So after connecting the sensors to the computer, you can simply run a certain test script. So by running this script, Python scripts test sensors.py, and by passing in the ORCA hand touch right as the argument, we can run the debug script. And as we can see now, we successfully connected to this serial port and we detected 5 sensors. We can see that the thumb and the pinky have 51 taxels. That's because they're smaller sensors. And the rest of them have 87 taxels. So now it asks us to the zero baseline, which means we are not going to touch the sensors, and tries to figure out what a potential noise is on those sensors. So by pressing enter, it reads some measurements, and now we go into phase 2 where we auto stream the resultant plus the finger force. And now it tells me to press on the thumb, and that's what I'm doing it now. And as you can see, we have some measurements of the resultant absolute force, the normal force. And we can repeat this for the index. There we go. For the middle, for the ring finger, and for the pinky. All right. And the phase 3 is where we test the individual taxels. And this is not the most beautiful visualization, but it should just show you what the overall structure of the sensor looks like. And currently we're all at 0, and if we move over a certain threshold, it shows us an X. And now for the thumb, this is what happens when we press on different locations. And we can do the same with index, and with the middle finger, ring finger, and pinky finger. And the phase 4 is a combined mode where we stream the resultants plus the taxels. And again, phase 5 is zeroing, so we just test again whether this is stable. And as you can see at the summary of the test, we see we've passed all tests, all phases, and we can see also we have a 91 FPS streaming. So this was a test script to understand what the modes of the sensors are, and if they're all wired up correctly, if they work, if the IDs correspond to the sensors. But I also want to show you how you can use this information in Python code. And for that I will just quickly open up VS Code, and we have a script here under scripts which is called example tactile. And how you would make use of this data in your custom programs is by just creating a hand object instance from this ORCA hand touch class. You make sure you import this ORCA hand touch. This time it's ORCA hand touch and not ORCA hand. And you pass the certain path in here. And then you can connect the hand. Either you can run connect or connect sensors only. Right now we do only connect sensors because again we have 2 separate ports for that. And by just activating this function start tactile stream with currently only the resulting force without taxels, we can then with this member function get tactile forces, get the individual forces, and then loop through them for every finger and print them. And of course then we can disconnect again. And by having different settings here, we can also activate the taxels, and then you get other objects returned. What I would suggest is just you can look at those functions in here in the ORCA hand touch class, which takes the ORCA hand as a base class. And we have different functions which are used for acquiring the tactile sensing data. We have a tactile client on the lower level, which abstracts the hardware. I hope this was useful, and I hope this makes it clearer how to use the sensing data of the ORCA hand. We have all the code here on our ORCA core GitHub repository. You can open up issues if there are any that you discover. Everything is open source all the way down to the lowest level. And we also have other repositories like, for example, ORCA Sim, ORCA Teleop, and ORCA hand description, which can be used to take Mujoko or URDF files and run simulations, or you can use the ORCA Teleop to control the hand with videos and with our retardator. in the meantime, happy building and have fun using the hand.